Good afternoon. Myself Vijay Krishna, Assistant Professor, Department of Mechanical Engineering, SRMIST, Katangulathur campus. Today I am going to give a video lecture on the topic radiative heat transfer. Here there are several modules. So today it is the first module about the introduction of this course. There are three modes of heat transfer like conduction, convection and radiation. So in which radiation is one of the basic mechanism. It happens between the two different regions at different temperature. Generally, radiation is transported by means of electromagnetic waves. In the universe, all the materials, all the matter have the tendency to emit thermal radiation when they have the temperature above zero temperature. If you compare the three modes of heat transfer, conduction, convection and radiation, in which radiation is the fastest medium of heat transfer, and it has the tendency to travel in the case of vacuum also. Radiation can able to happen in solids, liquid and gases. In most of the engineering applications, all three modes of heat transfer is possible. In the evacuated space, the significant heat transfer is the radiation. The examples of thermal radiations, there are lots of examples. So here we can tell the examples like a filament of a light bulb or thermos flask, and also radiation is possible in the energy conversion systems like a power plant which involve combustion and solar power plants. Apart from that, we have industrial heating, cooling and drying process, laser cutting and welding, climate control of buildings. We have automobiles, combustion chamber, cryogenic containers, high performance thermal insulation, solar craft and solar collectors, spacecraft, etc. Importance of thermal radiation. So mostly people will avoid radiation when the temperature is low. So mostly the radiation is considered when temperature is high. When we compare the radiative heat transfer with temperature, it is the non-linear profile. Mostly such phenomena, if we see where it happens like in IC engine, furnace or boiler or microwave oven, because there we can find the temperature in the range of 1200 degrees Celsius or 1500 degrees Celsius. There are examples like conduction. We can tell the example cooking on a metal pan. For convection, we have an example a small hot electronic board. For radiation, we have example a red hot to white hot material. If you see the heat transfer and temperature, how the profile. For conduction, it is a linear profile. For convection, it is weakly non-linear profile. When it comes to radiation, it is strongly non-linear with temperature. With respect to convection, there are two types of convection, that is free convection and forced convection. In free convection, if you see the delta T, that too in laminar flow, it is to the power of 1.25, whereas to the turbulent, it is to the power of 1.33. In the case of conduction, it is Q is directly proportional to the temperature difference. And for radiation, we don't need any medium. The example we can say that solar radiation on this earth. The professors like C. Balaji, they have mentioned strongly that radiation cannot be neglected in the low temperature, and also radiation is very significant in the natural convection or mixed convection, if the medium is air. In radiation, the significant features is frequency or wavelength. Mostly the propagation of radiation travels with the speed of light, and the product of frequency and velocity that gives the speed of light, and the value is around 3 into 10 power 8 meter per second. Mostly the wavelength of the electromagnetic radiation is represented by micrometer or angstrom. So 1 micrometer equal to 10 power minus 6 meter, whereas 1 angstrom equal to 10 power minus 10 meter. Nature of radiation. Generally radiations are explained in two ways. One is a wave model, another one is a quantum model. In wave model, the radiation is categorized by wavelength, frequency and speed, whereas when it comes to the concept like radiative properties of gases and black body radiation, only with wave model we cannot explain. So mostly in the radiative problem, both studies are essential, like wave model and quantum model. In wave model there are several attributes, and it is also characterized by a number of parameters, frequency, wavelength, and 1 by lambda, that is going to be a wave number, and we have refractive index. We have various types of electromagnetic waves. These electromagnetic waves are categorized based on the wavelength range. So we have gamma rays, X-rays, UV rays, infrared radiation, microwave waves and radio waves. If you see the electromagnetic radiation, the wavelength, the overall wavelength range of spectrum, it comes under less than 10 power 10 micrometer for the cosmic rays to the greater than 10 micrometer for the electrical power waves. But our concern only with the thermal radiation. That in thermal radiation the wavelength varies from 0.1 to 100 micrometer. Thermal radiation mostly consists of entire visible and infrared radiation and some part of the UV radiation. The energy carried by a photon, okay, that relation here we can see that energy equal to h into nu. So nu is the frequency and h is the Planck's constant. The value is 6.626 into 10 power minus 34 joule second. So the energy carried by photon, if you see, in which it is directly proportional to the frequency but inversely proportional to the wavelength. That means if you short the wavelength, the energy emitted by a photon will be larger. That's why X-rays and gamma rays have the tendency of short wavelength, but the energy what we are getting from those rays are enormous, and that too it is highly destructive and it must be avoided also. So there is one example from the problem natural convection. This problem taken from the Professor C. Balaji heat transfer book only. We have a vertical flat plate whose length is around 0.5 meter and it is maintained at wall temperature 373 Kelvin, and it is exposed to the quiescent air, and also that flat plate which has an emissivity of 0.9. And we have ambient temperature is around 303 Kelvin. Mostly these type of problem, the radiation is neglected. Only the convective heat transfer is determined. But Professor like C. Balaji, they have imposed that to this problem how much radiation is contributed. So they have calculated, in this simple problem we can see that radiation contribution alone it is around 57.8%. So it clearly shows that radiative heat transfer we cannot neglect in the low temperature application. So it is essential to consider radiation in low temperature as well as the high temperature applications. So there are two assignment questions which are given in the module, so that the students can solve these assignment questions also, and these are the references. So I thank the several authors whichever I referred. Thank them. Thank you all.